In this video, we're going to talk about the empirical rule, which is also sometimes called the normal rule, which is also sometimes called the 68, 95, 99, 7 rule. So what is it? This rule is just a quick way to show where you can find a certain percentage of your data within 1, 2, or 3 standard deviations from the mean. So 1, 2, or 3, pretty easy numbers to remember, and these percentages, 68, 95, 99, 7, correspond to those standard deviations. And when I say within, I mean on either side of the mean. So we're working with some symmetric percentages about the mean. So if you go out one standard deviation from the mean, you're going to find 68% of your data. If you go out 2 standard deviations, you'll get 95%, so almost all. Go out 3 standard deviations from the mean, and you're going to get almost all of your data, 99.7% of your data. So what must be required here? You have to have a normal or approximately normal distribution to guarantee these percentages. The further from normal you are, then you can't guarantee that you'll find that percent of data within that span from the mean. So there's a couple different ways to use this empirical rule, and we'll go through some examples. First, let's use the empirical rule and label a normal distribution. We're going to use the fact that on average, the number of faces a person can remember is 150 with a standard deviation of 20. This data came from some facts that I saw online, and specifically they were referring to Christmas cards and how many Christmas cards people were sending out, because you have to remember those people, and on average is about 150. The 20, the standard deviation, I just made that up. All right, so draw our normal model. So we'll try to make it fairly accurate. Get our horizontal axis there. We'll go up on one side, down on the other side. The mean is there, the center, 150. The points of inflection, about that flat part there, and we'll go symmetric on the other side just to make it easy. That is your 1 standard deviation mark. So that means we're going to go down 1 standard deviation. We're going to go down 20, so that's down to 130. And then on the other side, you go up to 170. Once you have these marks made, and pardon my artwork here, these numbers should be equally spaced, you can just start tacking in your extra numbers. So subtract 20 to get to 110, subtract 20 to get down to 90, and then do the same thing up here, up to 190, another tick mark up here to 210. So in our picture here, we went out 1 standard deviation from the mean, and this range right here, all of this data, if you can imagine this like a histogram with a blanket thrown on top and it makes this bell shape, this here is your 68% of your data. And that looks about like 2/3. That kind of makes sense. Now let's go out further from the mean. Go out 2 standard deviations. So now I'm talking about all this purple area plus this excess here. So from this mark all the way across, all the way here, this is where you see your 95% of data. And that kind of makes sense. If you ignore these tails, that could reasonably be about 5%. And then the last one, go out 3 standard deviations from the mean. So here, all the way across to here. And if I really shaded in everything here, all this stuff, that makes my 99.7%. And that's almost all. These tails would keep on going in either direction, but they'd keep getting flatter and closer to the horizon there, the horizontal line, and you're not catching any data, not much, 0.3% of it as you go out further and further. Okay, so here's our normal model. As messy it is, you can see 68%, 95%, and now 99.7% of your data within 1, 2, 3 standard deviations of the mean. So that gives us a picture of what's happening. Now let's ask some questions. What percent of people can remember between 110 and 190 faces? Well, this is just a matter of looking up at my histogram that my normal model that I've already drawn on. So 110, that was here, and 90, that was right here. If we know that the mean is right in the center, because I'm down 2 tick marks, I'm up 2 tick marks, I am 2 tick marks from the mean, so 110 and 190 are 2 standard deviations. I'm abbreviating standard deviation with SD. They are 2 standard deviations from the mean, from mu, 150. So your 2 standard deviations from the mean, go back up. We could scroll up here. 2 standard deviations from a mean, that gets you 95% of your data. So what percent of people can remember between 110 and 190 faces? It's 95% of people. And there we go, that's our answer, 95%. Example 3, now let's reverse this. Let's say 68% of the population can remember between what and what number of faces? Well, 68%, that is, with the empirical rule, 1 standard deviation from the mean. 1 standard deviation, that was 20. The mean was 150. So we need to add and subtract 20 away from the mean. So if I draw just an axis here, here's 150. I go up a standard deviation, I went down a standard deviation, I need to subtract 20, I need to add 20 on either side. So I get 130 and then 170. And these are my answers. So 68% of the population can remember between 130, squeeze that in there, and 170 faces. If we go back up to the picture, there's our 68%, that was just the purple area, and there's the cutoffs, 130, 170, just like we figured out ourselves. So this last problem, what percent of the population can remember between 130 and 210 faces? Let's go back up to our picture. What did it look like? Let's copy it down here. Oh, good. All right, here we go. Our question was about what percent of the population can remember between 130 and 210 faces. Well, 130 is right here. That was 1 standard deviation from the mean. 210, well, that was way up here. That was 3 standard deviations. So I'm going to write -1 standard deviation. I'm going to write +3 standard deviations. And notice that this is not symmetric. We have to do a little bit of math before we can get our answer. So what we're going to do is a little bit of subtraction. I'm going to start with this 130. So this blue area that I am showing here on the left, that is everything below that 68%. And I'm going to do one on the other side, above 68%. So if I have all of my data, that's 100%. If I subtract out a middle of 68, that leaves me with 32% unaccounted for. In other words, 32% is on either one of these sections. But 32% is the total. If I divide it by 2, that gives me 16%. Because I'm splitting 32% among 2 sides. There's 16% on each side. So of that cutoff of 130, 16% of people are below 130 faces that they can remember. Now let's do something similar, but this time with the 210. I'm going to put that in red right here. So 210, I'm looking at above 210. Go symmetrically down here, below 90. Take 100, subtract. 99.7. And we're going to get 0.3%. So 0.3%, just like we did with that 32%, we need to divide that by 2, and we're going to get 0.15%. All right, so all this math right here gives us this red area, 0.15%, and down below here, 0.15%. All right, so why did I need that? I only need to go between 130 and 210. If I cut out the part that's too high or the part that's too low, let's emphasize this, cut off the part that's too low, cut off the part that's too high, I'm landing with the percent of people straight in the middle. So my last calculation, I'm going to take 100%, subtract 16, because they are below 130, and then subtract 0.15, because they're above 210, and what's left, let's put in my percent sign, that's exactly in the middle between 130 and 210. And we get 83.85%. And that's our answer. So what percent of the population can remember between 130 and 210 faces? It's 83.85%.